Texas.
Not like people think you're so weird. You go to colleges, I'm like, hell no, I would never live there. It's just like we never went down south ever.
Yeah.
We just wanna go.
I've heard really good things about Texas.
We wanna go to Austin or something.
Yeah, I've heard really good things.
But I was like, Mom, I need to be tan if I'm gonna wear yellow, so we have to go.
That's very true. You could not be choosing yellow.
All right, let's just recap our special cases. So you all tell me, if I have log base b of b to the t, what does that simplify down to? T. See, you all know. If I have b raised to the log base b of t, that simplifies down to t. And basically these two shortcuts, but instead of log, we use ln. So if I have the ln of ln of e to the t, that's t. And if I have e raised to the ln of t, that is also t. And now you guys recognize that these two rules are the same and these two rules are the same. I've just interchanged, instead of log base e, I'm writing ln. It is the same rule. All right, two more rules that we know that we've been doing, we just haven't actually declared them as rules. Okay, the next one's going to be log base b of b equals 1. And I'll show you what I mean by that. So let's say I have, example, log base 2 of 2. And I ask you to simplify this. Well, isn't this saying 2 to what power equals 2? To 1. So anytime your base and your argument are the same without an exponent, it's always going to be 1. Anytime your base and your argument are the same without any exponent, it's going to be 1. And the very last rule is going to be log base b of 1 is equal to 0. An example would be log base 2 of 1. So this is telling us 2 to what power is 1? Well, there's a power that brings everything to 1. What's the power that brings everything to 1? 0. So we'd get x equals 0. So anytime you have a base and your argument is just 1, you know that has to simplify down to 0. The exponent has to be 0. Okay, so now what we're going to do is just practice simplifying. Did you need to go back, Tice? Up higher, is this good? Yeah, come. So let's say I have log base 2 of log base 3 of 81. We can figure this out, that parenthesis, like simplified, but you know what I'm going to do? I'm going to change it into shortcuts. How do I change this into a shortcut? Well, isn't this log base 3, and can I change 81 into 3 raised to the 4th power? 3 to the 4th power is 3 times 3 times 3 times 3. Now go back up. Didn't we have a shortcut for this?
Yeah.
Yeah, so what's log base 3 of 3 to the 4th? 4, right? So now we have log base 2, and this whole parenthesis simplified down to 4. Anybody confused with how we got 4 there? We're good? Okay, so guess what I'm going to do again? I'm going to change 4, even though we could probably do this in our heads. I'm going to change this into 2 squared. So now we have log base 2 of 2 squared, which is 2. All right, next one. All right, let's say we have log base 2 of 8 times log base 2 of 1/4. What is it that I don't want you to think this is? That's the question. What is it?
Hard.
Hard? No, it's not hard. That's true. I don't want you to think this is hard, but I also don't want you to think this is a shortcut. In the sense that where you can condense it. You're not allowed to say log base 2 of 8 times 1/4. This is not allowed. This is wrong. Why? Nika?
Is it not like combined anywhere?
In order for me to pull out that log base 2 and have 8 times 1/4, what operation would have to be here? Addition. There is no like condensing for multiplication. We're not allowed to pull out a log base 2 and multiply those arguments because we could only do that when there's addition between them. So what do I actually have to do? I have to simplify this side, and I have to simplify this side, and then multiply those two. Nika?
No, they're asking next thing, I think.
Sure, tell me.
Well, you could do like change the 8 into like 2 to the 3rd and just cross out the 2's.
You got it. We could change 8 into log base 2 of 2 to the 3rd, which is a shortcut. That's 3. For this next part, I'm going to change this into log base 2 of 4 raised to the negative first. What do you think I'm going to do with that 4 now? Yep, log base 2 of 2 to the negative second. So what does this whole thing simplify to? Negative 2. So then we have 3 times a negative 2, which is negative 6. Okay, I'm going to have you guys try this next one. So question for you, can I just pull out a log and multiply 8 and 1/9 together? Good, so why no? The log bases are different. You could only pull out the log and then multiply the arguments if their bases are the same. Their bases are not the same. So I can't pull it out and then multiply the arguments. So what you have to do is simplify the first one, simplify the second one, then do what? Add those two. You get a stylus? No.
I'm dedicated to paper. I use my notebook, I use it.
You're adding, not multiplying. All All right, let's go over this. So for log base 2 of 8, I'm changing this into log base 2 of 2 to the third. And then this side, I'm doing log base 3 of 9 raised to the negative first. We have log base 2 of 2 to the third plus log base 3 of 3 to the negative second. So now we simplify. This simplifies down to 3. This simplifies down to negative 2. But remember, we're adding them. So what's 3 plus negative 2? 1. Can I pull out a log base 2 here and then multiply the arguments? Yeah, how come this time I was allowed to do it, but in number 3 I wasn't? Jenny? Good, because this time they have the same base. So that's exactly what I'm going to do. I'm going to pull out a log base 2, and then I'll multiply 8 times 1/8. What's 8 times 1/8? 1. So this is log base 2 of 1. This was a shortcut. 0, very good. We good? Okay. So now I'm going to switch it up a little bit. I'm going to say given log 2 is A, log of 3 is B, and log of 5 is C. Find the given logs in terms of A, B, and C. When there's no base written down, what base is it? 10, good. Maya, only one color today?
I just don't want to be here. I'm sorry. I'm saying sorry to my sister.
I'm sad. Okay, so let's say I have log of 15. Well, I have log of 2 is A, log of 3 is B, log of 5 is C. I don't have log of 15, so I need to manipulate this argument. So I'm going to change this into log of 3 times 5. So now what I'm going to do is I'm going to expand this. The arguments are being multiplied. So what can I change this to? I could change this into log 3 plus log of 5. So go back to our given. Log 3 we said was B, and log 5 is C. So what do we end up with? B plus C.
So fun.
What's the point of doing that?
There's no point.
It's fun. It's fun.
Okay.
Let's try another one.
You should just do this from now on.
Log of 1 over 30.
Okay.
So first thing I'm going to do is what I always tell you to do when you have a fraction, change this into log of 30 raised to the negative first. Now I'm going to change 30. I'm going to change this into log of 2 times 3 times 5 raised to the negative first. Right? 2 times 3 is 6, 6 times 5 is 30. So I basically changed it into factors of 30. Now, When you have a log and an exponent, can I pull that to the front?
Yeah.
So this is going to be -1. And now I'm going to expand this times log of 2 plus log of 3 plus log of 5. Well, we said log of 2 is A, plus log of 3 is B, plus log of 5 is C. You can leave it like this, or what else could you do? Well, it's already factored out. You could multiply it back in. So you could have this answer, or you could have -A minus B minus C. Either answer is acceptable in my book.
So if it's like a number like 30, we can't like, make it smaller to get one of the numbers. You should like try to multiply the ones that are given, like you did.
Mm-hmm.
Okay.
All right, last section. We have 3 more problems and then we're done. So here I want us to solve for x. Oops, sorry, this is log base 7. Guys, remember the general format of a log, right? We have our log, base, answer equals exponent, right? Our argument is always our answer. So here, don't get confused that I've written multiple logs. I have a log, my base is 7. This is our argument. This is our answer. So when I go to change this back into exponential, I'm going to take my base, which is 7. What's my exponent? 0, right? It's whatever it equals. Log, base, answer equals exponent. So my exponent is 0, and then my answer is log base 3 of x. This is multiple steps. We're not going to get the answer in just one step. Well, what's anything raised to the 0 power? 1. So now this is saying 1 is equal, or switch it, log base 3 of x is equal to 1. Guess what I'm going to do all over again? Change it into exponential. My base is 3. This time my exponent is what? 1, and that equals x. So what does x equal? 3 to the first, which is just 3. Nico, this is what you were always asking me. Like, are we ever going to solve for the argument? Are we always just going to solve? This is it. We solved for the argument. Let's try another one. How about you guys try this one? Should we go over it? Okay, so remember, log, base, our argument is our answer, equals the exponent. So now I'm changing it into exponential. So my base is 5. What's my exponent? 1, that's going to equal the argument, which is log base 2 of x. Well, 5 to the first power is what? 5. So now we have log base 2 of x is equal to 5. I just rewrote it. I'm going to change it into exponential again. So I have my base is 2, my exponent is 5, my answer is x. 2 to the 5th power is 32. So x is equal to 32. How many people got that? All right, we'll do one more. Last one. Log base 7 of log base 4 of log base 2 of x equals 0. So we don't get intimidated by the length of this. No, we don't get intimidated. So basically, we look at the log that's on the outside of the parentheses. Which log is on the outside of the parentheses? Log base what? 4 is still inside parentheses. 7. So we're looking at the log base 7, and that we're going to start changing it to exponential from there. So the one on the outside of my parentheses is going to be my base. What's the exponent? 0. And this whole thing is my argument, right? Everything inside the parentheses is always the argument. So this is going to equal log of 4 of log of 2x. Log base 2 of x. Well, what's 7 to the 0 power? No, not 0. 1. Anything to the 0 power is always 1. So now we have log base 4 of log base 2 of x is equal to 7 to the 0 power, which is 1. I just rewrote it because I like seeing everything on the left side. All right, which log is outside the parentheses this time? 4. So now we're going to use that as our base, log base 4. So now I'm going to say 4 to what power? 1. 4 to the first power is equal to what? What'd you say, Tice? You got it, log base 2 of x. Well, what's 4 to the first power? 4. So I'm going to rewrite this, log base 2 of x equals 4. Change it back into exponential one last time. How do I change this last part into exponential? 2 to the 4th is equal to x. And what's 2 to the 4th power? So x is equal to 16. All right, we are done for today. Next class, we're just going to practice